Mutations cannot be produced according to need. You can't have a creature that would love to fly. Let's say some reptile saying, I'd really like to fly. I think I'm going to put a lot of thought to it and evolve some wings. It doesn't work that way. Random, purposeless, goalless mutations would have to come up purely by chance, with no objective or goal in mind, come up with all of the genes, all the integrated gene products to produce wings, and then you could select for it.
They believe that one kind of animal changed into another, but the study of genetics shows you can have great variation within a kind, you can see natural selection, you can see speciation, but it's always within a kind, and the biblical kind is more like a family level of classification, phylum, class, order, family, genus, species.
The problem is those mechanisms don't work. I mean, we know from science today, what we call observational science that we can do in the lab, we know that yes, mutation does occur, and natural selection does occur, but it doesn't add anything. It doesn't make new structures. It doesn't make new things. You can't go from an apple to a lemon, so to speak. You're not going to get there by the mechanisms that we know of today, by mutation, by natural selection. Now, they might say, well, there's some mechanism we just don't know about. Okay, you know, and so that's a problem, and that's why it really helps us know. That's why we have to go back to our starting points. What are our starting points? Is it that God did this, or is it that nature did this by itself?
Some mechanism that we're just not quite sure about. You can tell she's not happy at all with that answer. She's looking for something more. And watch for it. You'll notice a little later that Dr. Myers makes the exact same statement. He's just not quite sure. Are you happy with that answer?
You start with a fish that is living in a marginal environment, kind of brackish water perhaps, or water that's, you know, sometimes gets rather unpleasantly stagnant. And what you've got there is a fish that needs a way to breathe. And what they'll do is initially they'll do simple things like gulp water, or gulp air. I mean, they'll rise to the surface and take a gulp of air, and that gives them the oxygen to keep going. And we've got fish like that do this right now. Then there would have been other adaptations, things like building stronger fins because they're in shallow water, and they need, sometimes if you're in really shallow water, it's more efficient to use your fins to move along the muck rather than to swim as a more deep water fish would do. And these fish acquired a set of pre-adaptations. They acquired a set of properties that allowed them to cope with the environment outside the water. And so it was a fairly small step after that for one of the fish to emerge, you know, not all the time. It would come out every once in a while to get a snack of cockroaches in the land or whatever. And then there's selection now for these land fish to be more and more tolerant of an arid environment.
Notice the fairly fine point that we cannot self-select mutations that we think will be advantageous to us. This, of course, from an anatomist, and this flies in the face of what P.Z. Myers is suggesting when he's talking about the fish that, you know, begins to find a way to adapt its fins so that it can effectively walk in the shallow water, of course, eventually setting its offspring up to be the first fish that walked up onto dry land. If we can't select for mutation, then it just happens by chance. And I think that is perhaps the hinge of much of this debate. Do things happen by chance, or do they happen by design? You're going to have to answer that one for yourself.
We define evolution as molecules to man, okay, going from some sort of single-cell organism to people today. Whereas what they talk about a lot of times, or what they're seeing, is when they say evolution, they're seeing things on a very small scale, so to speak, changes within a kind of animal, like the Bible talks about. Like, we see this today, we see this happening, but they're saying, oh, just give it enough time. If you just give it enough time, you're going to see, you know, whatever, a dinosaur evolve into a bird. But the problem is the mechanism does not work. Mutations and natural selection simply don't do that.
Nothing's perfect. Everything has to change a little bit. And so what we've got is chance mutation that's generating a diversity of forms. And then you've got selection that's imposing itself on these. And those forms that happen to have a combination that makes them most efficient at replication will then take over the environment.
See, the key is, how do you get genetic information? How do you get information that'll make a placenta or a liver or a kidney? or an eye. This isn't just a single dumb luck stroke. This is a whole integrated system of complexity. Sort of like when the symphony orchestra plays. When they're tuning up, you think, no way, we're not going to get any music out of this group. It's chaos, but the conductor goes tick, tick, and the music happens and it's beautiful. And you went from complexity to integrated complexity.
See, the word science means knowledge. And usually we use the word science to talk about our technology, you know, observational science, ability technology, but you can have knowledge concerning history and knowledge that you gain by observation.
Because when you're talking about science, what you're talking about is a process that is built on evidence, that we have to have ways to test our hypotheses. That's fundamental to doing good science.
A scientist wants to understand cause, so that you didn't simply look at the Earth and record, well, where is this kind of rock or that kind of mineral, but try to understand why it's exactly the way it is. And the evidence became overwhelming that there was a history to it. Lyle proposed the principle that scientifically we should always prefer to find causes that we can understand.
Creationists and evolutionists all have the same observational science. That's why you can have a creationist and evolutionist working side by side on the Hubble telescope, or building a jet aeroplane, or working in a laboratory mixing chemicals together, because they're the things you can all do in the present and agree upon. A creationist and an evolutionist can build a rover spacecraft and put it on Mars, and they'll agree on that. But what they disagree on is the origin of Mars. So that's the real issue. That's the difference, and that's what we need to understand.
Probably the most common objection is that we're not doing good science. We're not scientists, we're not doing good science. Even though I have a PhD from a well-respected university, I'm not doing science. But again, it goes back to the definition of what is science, okay? And we need to really divide it into two categories. Are we talking about science that we go in the lab and do? Because I can do that just like anyone else can. And really what I do in the here and now, as far as science in the lab kind of thing, that gives us MRIs and airplanes and vaccine, has nothing to do with Darwin. Nothing.
Scientists and their worldviews collide as the great debate continues right after this.